Dawn, late winter, a high plateau at the edge of the northern steppe. The light arrives slowly here, sliding across frost-stiffened grass and stone. Wind moves low over the ground, carrying the dry scent of snow that has not yet fallen. Below the ridge, the land is quiet. No bird song, no insect hum. Only the faint scrape of ice loosening from rock as temperatures rise by degrees, not leaps. Near a shallow ravine, a red fox moves through shadow. Its coat blends into pale earth, muted by dust and cold. Each step is measured. Ears tilt, adjusting to sounds too small to name. The click of old claws beneath frozen soil, the distant rustle of grass pressed flat by night wind. The fox pauses often, not from hesitation, but calculation. Above, far above, an eagle rides the first thermals of morning, wings spread wide, barely beating. From this height, the landscape compresses. Movement becomes signal. Contrast becomes opportunity. Its eyes search not for form, but for error. Two predators occupy the same ground, bound by the same scarcity. One lives close to the earth, solving problems step by step. The other commands the sky, built for decisive force. Neither seeks the other. Yet here, their paths will cross, not by intent but by necessity. The red fox, Vulpes vulpes, is among the most widely distributed terrestrial carnivores on Earth. Its range spans the northern hemisphere, from Arctic tundra to desert margins, temperate forests to agricultural plains. This success is not the result of strength or speed, but of adaptability. Foxes are generalist predators, shaped by evolutionary pressure to survive in environments that change faster than specialization allows. Their bodies are lightweight, their jaws relatively narrow, their limbs built for endurance rather than power. What defines them instead is behavioral flexibility. Foxes rely on a mixed strategy of opportunism and precision. Their diet reflects this. Small mammals such as voles and mice form the bulk of their intake, supplemented by birds, insects, carrion, fruit, and human-associated food where available. Studies using scat analysis across Eurasia and North America show seasonal shifts in diet composition that closely track prey availability rather than preference. In winter, when rodents move beneath snow and ice, foxes increase reliance on cache food and scavenging. In spring, they pivot rapidly toward emerging prey. This dietary elasticity reduces the risk of starvation, but demands constant information gathering. The fox survives by knowing its environment in detail. Its sensory world is tuned for this task. Hearing is acute, particularly in low frequencies generated by subterranean prey. The characteristic pounce, where a fox leaps and plunges its forepaws into snow, has been shown in controlled studies to rely on magnetic alignment, improving accuracy when prey is hidden from view. This behavior is not instinct alone, but learned refinement layered over instinct, adjusted through repetition and feedback. Young foxes practice extensively before success becomes reliable. Above the same landscape, the eagle operates under a different evolutionary logic. Large eagles, such as the golden eagle, Aquila cressidos, are apex aerial predators, evolved for power, reach, and decisive force. Their wingspans can exceed 2 meters, designed to exploit thermal currents and conserve energy across vast territories. Their skeletal structure is reinforced. Their talons are curved and muscular, capable of exerting crushing pressure sufficient to kill medium-sized mammals instantly. Unlike foxes, eagles are specialists in the act of killing. Eagle vision is among the most advanced in the animal kingdom, with a density of photoreceptors far exceeding that of humans. Eagles can detect movement at distances measured in kilometers. They are particularly sensitive to contrast and motion, allowing them to isolate prey against complex backgrounds. This visual acuity compensates for the lack of flexibility seen in generalist feeders. An eagle's success depends on identifying the right moment, then committing fully. The ecosystems where foxes and eagles overlap are structured by scarcity and exposure. Open habitats, steppes, alpine plateaus, tundra margins, offer limited cover. Prey populations fluctuate sharply with weather, snowfall, and plant growth cycles. In such systems, competition is indirect but constant. Foxes and eagles often target the same small mammals. They do not hunt each other as primary prey, but their interactions are shaped by mutual awareness. Research conducted in Mongolia, Scandinavia, and Western North America documents instances of eagles preying on fox kits and, more rarely, adult foxes. These events are uncommon, but ecologically significant. They remind smaller predators that size confers vulnerability, not dominance. Conversely, foxes are known to scavenge from eagle kills, approaching cautiously after the bird is fed or been displaced. Camera trap studies reveal foxes timing their visits to carcasses in relation to eagle activity, demonstrating learned avoidance rather than confrontation. Within the food chain, neither animal exists as a moral counterpoint to the other. The fox reduces rodent populations, indirectly influencing vegetation recovery and soil structure. The eagle regulates mid-sized prey and occasionally suppresses mesopredator numbers, including foxes, through predation pressure. This dynamic contributes to trophic balance, preventing any single adaptive strategy from becoming absolute. Their coexistence is not a rivalry of intention, but of consequence. Each has evolved to solve survival in opposite ways. One through cognitive mapping of a complex ground-level world, the other through overwhelming force applied from above. When their paths intersect, the outcome is never symbolic. It is conditional, shaped by weather, terrain, timing, and error. In evolutionary terms, the divergence between fox and eagle represents two solutions to the same problem: how to secure enough energy to reproduce in an environment that offers no guarantees. The red fox's lineage emphasizes neurological investment over physical specialization. Relative to body size, foxes possess a highly developed cerebral cortex compared to many carnivores. This supports memory, spatial awareness, and behavioral plasticity, traits repeatedly documented in urban and rural populations alike. Foxes learn routes, cache locations, seasonal patterns, and individual risk zones. Long-term field studies in the United Kingdom and Germany show that foxes can remember the locations of dozens of food caches for weeks, adjusting retrieval based on spoilage and competition. This intelligence is paired with restraint. Foxes rarely commit fully unless conditions favor success. They test, retreat, and reattempt in predator-prey models. This reduces injury risk, which is critical for an animal that cannot afford damage. A fox with a broken limb or punctured lung will not survive long. As a result, fox behavior is shaped as much by avoidance as by pursuit. This is evident in their responses to aerial predators. Foxes demonstrate heightened vigilance in open terrain, frequently pausing to scan the sky. Their travel routes often follow hedgerows, gullies, and terrain breaks, minimizing exposure from above. Eagles, by contrast, embody a high-risk, high-reward strategy. Their evolutionary success depends on the ability to overpower prey quickly and efficiently. The cost of a failed strike is significant in terms of energy expenditure, but less so in physical risk. An eagle's anatomy is built to absorb impact. Talons strike first, targeting the spine or thorax. The beak follows only after control is established. This sequence is fixed, honed over millions of years, and leaves little room for improvisation. Eagles do not learn dozens of strategies. They perfect a few. Their ecological role reflects this specialization. Eagles require large territories with sufficient prey density to offset long intervals between kills. Satellite tracking studies show that golden eagles may range over hundreds of square kilometers, adjusting flight patterns to weather systems and prey movement. When prey declines, reproductive success drops sharply. Eagles lay fewer eggs, and chick mortality increases. This sensitivity to resource availability contrasts with fox populations, which tend to fluctuate less dramatically due to dietary breadth. The interaction between fox and eagle is shaped by asymmetry. On the ground, the fox holds the advantage. It can disappear into cover, change direction unpredictably, and exploit microhabitats inaccessible from the air. In the open, the balance shifts. Snow covers short grass, or rocky flats remove concealment and expose movement. In these conditions, foxes modify behavior markedly. GPS-collared foxes in alpine regions show reduced daytime activity in open areas, increasing nocturnal movement when eagles are less active. This temporal partitioning is a direct response to predation risk. From the eagle's perspective, foxes represent an opportunistic target rather than a staple. Adult foxes are agile and alert, and a failed attack carries a risk of injury from bites or evasive maneuvers. Most recorded eagle-fox predation involves juveniles, weakened adults, or moments of environmental constraint. Deep snow, strong headwinds, or surprise at close range. These encounters are not frequent, but they influence behavior disproportionately. The mere presence of eagles alters fox movement patterns, a phenomenon known as the landscape of fear. This dynamic has cascading effects. By limiting fox activity in exposed zones, eagles indirectly reduce predation pressure on small mammals in those areas. Vegetation recovery may follow, altering insect populations and soil stability. Such trophic interactions are subtle, unfolding over seasons rather than moments, and are often invisible without long-term study. In this system, neither intelligence nor strength is inherently superior. Each is effective only within the parameters that shaped it. The fox's brain is a tool for negotiation with uncertainty. The eagle's brawn is a tool for resolution. When they intersect, the outcome is not a contest of ideals, but convergence of evolutionary histories, played out in real time. The first angle is survival biology, written into muscle and nerve. For the fox, survival depends on minimizing exposure. Its body mass is low, reducing caloric needs but increasing vulnerability to cold and injury. Heat conservation comes from fur density and behavior rather than fat reserves. Foxes curl tightly when resting, reduce movement during extreme cold, and select den sites that balance insulation with escape routes. Every decision is weighed against energy cost. This economy shapes how the fox moves through shared territory, never lingering long in open ground, never committing to a path without alternatives. The eagle's survival biology moves in the opposite direction. Its mass is an asset. Large pectoral muscles power flight, while hollow bones reduce weight without sacrificing strength. The respiratory system allows continuous oxygen flow, supporting long glides at altitude. This physiology favors dominance of space rather than concealment. The eagle does not hide. It positions by controlling airspace. It reduces uncertainty. Survival comes from controlling when and where engagement occurs. The second angle is strategy, hunting versus avoidance. Fox hunting is iterative. A fox may investigate dozens of potential prey signals before committing. Failed attempts are expected and absorbed into the day's energy budget. This tolerance for failure allows flexibility. The fox does not require a single decisive moment. Instead, it accumulates small successes. This same strategy governs its response to danger. When an eagle appears, the fox rarely panics. Instead, it alters posture, reduces movement, and angles toward cover. Observational studies show foxes freezing rather than fleeing when raptors pass overhead, reducing visual contrast that could trigger pursuit. Eagles operate differently. Their hunting strategy is binary. A strike is either launched or withheld. Once committed, the outcome is resolved within seconds. This demands certainty. Eagles spend long periods observing, conserving energy while evaluating angle, wind, and prey awareness. When they strike, it is with full force. Against foxes, this strategy requires conditions that strip away the fox's advantages: surprise, limited escape paths, or environmental constraint. The third angle is intelligence versus instinct, not as opposites, but as gradients. Fox intelligence is expressed through learning and memory. Individuals differ markedly in behavior, shaped by experience. Some foxes become bold scavengers, others remain strictly nocturnal. This individuality has been documented in long-term population studies, indicating cognitive flexibility rather than fixed programming. A fox that survives an eagle encounter may permanently alter its range or activity pattern. Eagle behavior shows less individual variation, but greater refinement of instinct. Their actions are precise, repeatable, and optimized. Learning occurs mainly in juveniles, who practice attacks and suffer high mortality. Those that survive emerge as efficient predators. The eagle's mind is not complex in breadth, but it is exact in focus. These angles do not compete. They coexist. Each reveals how different evolutionary paths solve the same problem: staying alive in a world that offers no safety. Another angle emerges through parenting and generational survival. Foxes invest heavily in parental teaching. A breeding pair often shares responsibilities. With the vixen remaining close to the den, while the male provides food during early weeks. As kits mature, adults introduce live prey, allowing young foxes to practice capture techniques in controlled circumstances. Field observations show parents intentionally releasing injured but mobile rodents near the den entrance. This staged exposure builds coordination and hunting timing. Survival for fox offspring is not guaranteed, but is actively supported through behavioral education. Mortality remains high, especially in the first year. Yet those that survive inherit not only genetic traits, but learn caution shaped by parental influence. Eagles follow a different generational model. Investment is concentrated but selective. Most eagle species raise 1 or 2 chicks, though often only the strongest survives the fledgling due to resource competition. Parents deliver prey, but provide minimal structured teaching. Instead, young eagles develop through observation and repetition. They test flight boundaries, misjudge wind currents, and practice strikes on inanimate objects or small animals. The mortality rate among juvenile eagles is extremely high, with studies suggesting that only a fraction survive their first year. This system favors producing individuals capable of independent mastery rather than cooperative learning. A further angle lies in territorial coexistence and rivalry. Fox territories are fluid and often overlap, especially where food sources fluctuate. Scent marking establishes presence, but conflict is usually avoided through temporal separation. Foxes may share landscapes with other foxes by hunting at different times or focusing on slightly different prey sizes. This adaptability extends interactions with larger predators. Foxes regularly exploit territories occupied by wolves, lynx, or eagles, moving cautiously along the edges of their influence zones. They operate in the margins, where risk exists but opportunity remains. Eagles maintain far more rigid territorial boundaries. Breeding pairs defend nesting cliffs or tall trees with consistency across years. Territory size is dictated by prey density and topography, but defense is aggressive, particularly during breeding season. Intruding raptors are often chased or attacked. Foxes rarely provoke direct territorial response from eagles, yet they remain monitored as potential competitors for carcasses or opportunistic prey targets. This creates a silent spatial negotiation, where foxes learn the flight patterns and hunting perches of resident eagles and adjust movement accordingly. The final angle is nature's neutrality. Neither fox nor eagle represents cunning or brutality in moral terms. Their behaviors are expressions of environmental pressure and biological design. The fox's caution is not cleverness in the human sense. It is survival shaped by vulnerability. The eagle's power is not cruelty. It is efficiency required by a body built for rapid, lethal strikes. In ecological systems, success is measured only by continuation of lineage. Every interaction, whether avoidance, scavenging, or predation, feeds into a broader equilibrium that stabilizes prey populations and resource distribution. In landscapes where fox and eagle coexist, their relationship becomes a study in balance between subtlety and force. The fox shapes the ground through constant, small interventions in prey populations. The eagle shapes it through sudden, decisive acts. Together, they form overlapping layers of predation pressure that ripple through vegetation, rodent numbers, and even soil composition. Their coexistence is not harmony nor conflict. It is an ongoing adjustment, recalculated with each season, each birth, and each death. Midday, early spring, the plateau has shed its frost, but not its restraint. Snow lingers in hollows, hard and granular, reflecting light upward and flattening contrast across the land. The wind has strengthened, moving in steady bands that press the grass low and erase sound before it can travel. The fox emerges from cover, drawn by necessity rather than confidence. Winter has narrowed its margins. Cache food is nearly gone. Rodent activity has not yet rebounded. Hunger sharpens risk tolerance. It moves into open ground, pausing often, head angled low, ears forward. Each step leaves a shallow imprint in the softened crust of snow. Above, the eagle is already present. It has been circling for nearly an hour, riding uneven thermals that break along the ridge. From this height, the fox is not yet prey, only a possibility. The eagle watches for patterns, pauses that last too long, movement that follows predictable lines, hesitation that suggests fatigue. Wind direction is tested with subtle shifts of wing and tail. Nothing is rushed. The fox begins to dig. Beneath the snow, a vole tunnel collapses inward. The fox commits, forelimbs striking repeatedly, body angle forward. Its attention narrows. For several seconds, its world shrinks to sound and vibration beneath the surface. This is the moment the eagle has been waiting for. The descent is silent at first. Wings fold partially, reducing drag. Gravity accelerates the body, converting altitude into speed. At this angle, the fox's peripheral vision is limited by its posture and the glare of reflected light. There is no alarm call in this landscape, no other animal to signal danger. At the last instant, the fox senses displacement, air pressure changing, shadow breaking pattern. It reacts without analysis. The dig is abandoned. The body twists sideways, hind legs pushing hard against the snow. The movement is not elegant, but it is immediate. The eagle strikes where the fox was meant to be. Talons rake across fur rather than flesh, catching briefly at the shoulder before slipping free. The impact throws both animals off balance. Snow erupts upward, obscuring vision. The eagle beats its wings hard to regain altitude, lifting away with effort rather than ease. On the ground, the fox does not chase distance. It chases cover. It runs low and erratic, altering direction twice within seconds, aiming not for speed but for obstruction. A shallow ravine breaks the surface ahead. The fox drops into it and disappears from view. The eagle climbs, circling once, twice. The opportunity has passed. Energy has been spent. The fox is no longer visible, its movement absorbed by terrain. The eagle does not pursue blindly. It drifts back toward the ridge, resuming its watch, scanning for the next imbalance in the landscape. Below, in the ravine's shadow, the fox remains still. Breath comes fast. A shallow tear in the fur leaks heat, but no blood. The encounter is over, not because one animal prevailed, but because conditions shifted. Wind, light, posture, and timing have reasserted control. This was not a battle. It was a convergence, brief, precise, and unresolved. The plateau settles again, but its tension does not dissipate. The fox remains in the ravine long after its breathing slows. Muscles tremble, not from fear, but from exertion and adrenaline. Energy lost now must be repaid later, in calories not yet secured. The fox does not emerge until the angle of the sun has shifted, reducing glare and restoring contrast along the ground. When it does move, its behavior has changed. Travel is tighter, hugging terrain, avoiding even marginally open stretches. The fox's range contracts not permanently but decisively. Studies tracking post-predation encounters show similar patterns. Animals that survive an aerial attack reduce exposure for days, sometimes weeks. The memory of near contact alters decision-making long after the physical risk has passed. Above, the eagle adjusts as well. A failed strike is not ignored. The bird ascends to a higher glide path, reassessing the landscape. It relocates to a different perch, altering its angle of observation. Eagles have been documented modifying hunting routes after unsuccessful attempts, especially when prey demonstrates heightened vigilance. The fox, now alert, is no longer an efficient target. The eagle's attention shifts toward other movement. Hares emerging near snowmelt lines, ground squirrels testing new burrow openings. The decisive moment has already occurred, but its consequences continue to unfold. The encounter has redistributed pressure rather than resolved it. Both predators remain hungry. Both must recalibrate. As afternoon advances, wind patterns shift. Thermals weaken. The eagle descends to a rocky outcrop to rest, conserving energy. It preens briefly, checking feathers for damage. None is found. The fox, meanwhile, resumes hunting in confined spaces, working along the ravine edges where rodent tunnels converge. Success comes slowly. A single small vole captured near dusk. It is not enough to erase deficit, but enough to stabilize. These outcomes reflect a broader pattern observed across ecosystems. Predation does not require death to exert influence. Attempted kills shape movement, timing, and risk tolerance across species. Ecologists refer to this as non-consumptive effects, impacts that ripple through behavior without physical removal from the population. In this case, the eagle has altered fox behavior for days. The fox has, in turn, avoided becoming prey without direct confrontation. As night approaches, the eagle's dominance recedes. Darkness limits visual acuity. The fox's advantage returns. Activity increases under low light, where auditory cues replace visual exposure. The balance shifts again, as it always does. The climax was not marked by victory. It was marked by recalibration, an exchange of pressure that reinforces boundaries neither animal consciously defines, yet both obey. In the days that follow, the landscape carries subtle traces of the encounter, though nothing visible to an untrained eye. No feathers scattered, no blood darkening the snow. Yet behavior has shifted, and in ecological terms, that is consequent enough. The fox's movements remain compressed. GPS studies of macaw predators exposed to aerial attacks show reduced range use and increased reliance on linear features, ravines, brush lines, stone breaks, for extended periods. This fox follows the same pattern. Hunting becomes more deliberate, favoring locations where escape routes are immediate and overhead visibility is broken. The cost is efficiency. These areas hold fewer prey, and each capture requires more time and effort. The fox's body weight drops slightly over the following week, a measurable but survivable loss. Physiologically, the encounter leaves little permanent damage. The shallow tear in the fur heals quickly, insulated by dense undercoat, but the metabolic toll persists. Stress hormones elevate briefly, then normalize, yet the fox's energy budget remains tight until prey availability improves with advancing spring. This is typical. In long-term studies, near-miss predation events correlate with delayed breeding or reduced litter size in some individuals, suggesting that survival alone does not guarantee full reproductive recovery. The eagle's aftermath unfolds differently. From its perspective, the failed strike is absorbed into a larger pattern of attempts and successes. Raptors are built for variance. A missed opportunity does not threaten survival unless repeated frequently. Over the following days, the eagle compensates by shifting prey focus. Observations from alpine and steppe regions show eagles increasing attention to species whose vigilance is lower. Juvenile hares, ground squirrels emerging from hibernation, or carrion exposed by thaw. The eagle's territory remains unchanged. Its dominance of airspace is intact. Yet the fox's absence from open ground slightly alters prey behavior below. Rodents venture farther from cover during daylight hours. Grazing pressure on early vegetation increases. These are minor changes, but multiplied across many similar interactions, they shape the rhythm of the ecosystem. Importantly, there is no escalation. The eagle does not hunt the fox again in the following weeks. The fox does not abandon the plateau. This restraint is not conscious avoidance, but statistical reality. Predators optimize for probability, not revenge or rivalry. Once risk outweighs reward, attention shifts elsewhere.